Okay, welcome to Nested Loop session 10. We're going to do, what number is this one? It is
I think it's 12.
Chapter 12. It is How Experts Design. I'll turn it right over to Andrew. And it may run short, but that's okay. This chapter is kind of shortish. So go ahead.
Great. All right, guys. So this is Chapter 12, How Do Experts Design? Just a little bit of an overview. This chapter is based on a book by Christopher Alexander called The Timeless Way. So in this overview, we can see how our author goes through and highlights how Christopher uses patterns to define design. I found that the author didn't put in a lot of description of the book, so I took the liberty of just looking up the table of contents and then just kind of using a summary of that book just to give us some sort of basis of what he's talking about. One of the things that I found, Alexander's book is pretty abstract. There's some abstract experience, I feel like, so it's very generalized. I do want to read this book later, just to see if I get to understand it. I'll just conclude with this chapter is meant to discuss Alexander's approach to design and then how to apply this to software. So Christopher Alexander wrote The Timeless Way, and it's split into 4 more or less parts. The first is called The Timeless Way, The Quality, The Gate, and The Way, and I included a link to where I got this information. This is just straight from this Google Books website of the Timeless Way, and the author already puts Christopher Alexander already puts like a small description of each as part of his table of contents. So I just kind of lifted it and put it into this presentation. So the Timeless Way, it is a process which brings order out of nothing but ourselves. It cannot be attained, but it will happen on its own accord if we let it. So it kind of just means that it evolves out of nothing. It's a very abstract kind of expression, but he builds on top of that, which is pretty interesting because that's the essence of what he's trying to show with design. He's like setting out to start from a very, very, very basic idea and then to build on top of that, which kind of is the theme of this chapter. The next section is called The Quality, that it's the criterion of life found in everything, and it's defined by certain patterns of events that keep on happening there. So it's a very essential quality found in buildings and people that he's trying to describe using the Timeless Way. And then he goes on to say that examples of dead patterns or live patterns, that patterns keep us locked in a rigid and unflexible or something that can't change, whereas an alive pattern allows for change in the future. And goes on to give an example of what alive patterns do compared to dead patterns. The gate is a little bit more complex. He introduces that there are a language of patterns. He expresses that these patterns are dead, and our job in this book is to build towards creating new patterns. Build towards creating a new language of patterns. And the idea is that a collection of these language of patterns allows for a robust design, and this is called the gate. The way. This is how the design evolves. It's kind of builds on top of itself. You start from a very simple thing and you start complexifying it one by one. I like to think of this almost like functional programming. You define numbers by functions, which is very abstract, and you just keep on surrounding a function with another function to get something out of it. It's something I want to flesh out more. I don't really see our original author kind of make that connection, but this is more of a upper level design rather than a very like structured language connection between the two of the timeless way and complex functional programming. So that's the overview. Go into the next, which is kind of our original author kind of defining the timeless way. So the timeless way of building is both about patterns and how they work together. It allows us to understand the environment in which we live in, and it's something that our author is going to try to describe. So how we normally view design. Essentially, how we normally view design is how I interpret it as having a different set of Legos, bricks or Lego blocks. You have different shapes and you've built with them before, and you get to create really, really cool designs with these prefabricated Lego bricks. And that's how we've, the author argues, that's how we've always learned how to build. We make very robust, we make very good standardized pieces, and then we try to put them together to achieve something. However, he finds that there might be some problems with that it's not organic enough, that it's impossible really to define nature just using these predefined pieces. You might have to try to approach it from another way, and you can't approach it from another way if you start off with predefined pieces. It's almost like you can't solve an algebra problem by using poetry, in a sense. That's worse. I'll forget that one. Go to the next one. Reading this book, he opened his mind, thinking that perhaps I'll try to abandon using preformed parts and try to look at everything from the whole. So when parts are modular and made before the whole, by definition, they are identical, and it is impossible for every part to be unique. Even more important, it is simply not possible for any combination of modular parts to contain the number of patterns which must be present simultaneously in a place which is alive. This is kind of going back to patterns that are alive versus patterns that are dead. The Lego bricks are patterns that would be defined as dead. Good design handles specific needs. I'll just read the highlighted. What he means is that if one starts out building modules before having the big picture, it is unlikely that modules be able to handle special needs. And that good design requires keeping the big picture in mind. Let's see. So an example are villages. So he talks about Swiss villages. They're very organic in the way they develop. They might have different resources, so some buildings look much better than others, while others might have a different kind of personality. He uses that to say this is kind of an alive pattern, something that kind of builds from what's available and isn't made from prefabricated parts. He says the effect is very nice and a comfortable image. Whereas an American suburb, he goes on to say, is more of a prefabricated, almost like a conveyor belt sensei thing, looks the same and should look the same, and it's regardless of, you know, different inputs. It feels like it's all kind of, it ignores all the things that a Swiss villages takes into account when they build organically out of each other. And he says that the effect is depersonalization of the houses and is not at all pleasing. Oops. So a main tenet of this is the complexification. This was the way, I believe. So the way is how a design slowly emerges from something very simple and starts complexifying, starting to take shape in that sort of sense. He calls it the differentiating process. It views design as a sequence of acts of complexification. Structure is injected into the whole by operating on the whole and crinkling it, not by adding little parts to one another. In a sense, the whole gives birth to its parts. The form of a whole and its parts come into being simultaneously. So he uses the image of an embryo kind of emerging. This is a good, I like to think of this kind of as operators in a sense. If you take a state, for instance, and you apply an operator to it, you both change the state originally sometimes and kind of create something new out of it. Slowly you start adding more and more operators and you get this final object that's quite different from what you started off of, but it's just the complexification, which is a good word for it, of just applying more and more of whatever the operator might be. It could be like, increase. Well, we'll go into the next example, which is he takes a classroom. So he starts off with a 30 by 30 foot space, and that's the initial thing. And it's like, okay, but I need a theater style of chairs. So imagine it's like, all right, now you apply that kind of operator of adding chairs to a room, and now in the end you have a room with 4 rows of 8 chairs. And then continuing on, you kind of just add on top of that, and that kind of adding on top of is complexification. This example is a little too general, but maybe we can come up with, but we can see that each pattern is an operator that differentiates the space. That is, it creates distinctions where distinction was not there before. The operations are arranged in a sequence, and it's kind of interesting. We can talk about like, oh, what if you add, the lectern before the chairs, or what if you add, the paint after the chairs, you paint the chairs. So the idea of that perhaps in adding operations, in order becomes important, whereas if you're building from modular pieces, it doesn't matter at what time you add a certain piece. They all just kind of glom together because they're all predefined, whereas we add definition based on the operations and the order that we apply them. Something to talk about maybe later. Another example is the courtyard. You start off with an open space and you start adding more differentiating features to it. Perhaps you want open spaces in the courtyard, so you make sure you have open spaces. You like clear whatever like trees were there, and then you start saying, well, we want paths to cross. So now you start designing, along the open space and making sure that as you're applying these things, nothing kind of conflicts in a bit. And so there's this kind of like, you have to remove to add mentality going on. Again, that's a little bit different from having modular pieces in a sense. You might have something that says open spaces and you can't have it. Again, it gets really tricky, and hopefully later on we'll go on to say if there's a way to have modular pieces, because I feel like I'm still very used to thinking in modular pieces. We refine the design of the courtyard by thinking about the patterns that would exist in the context of the courtyard pattern, such as porches or verandas facing the courtyard. So how the design process unfolds. What makes this analytical method so powerful is that it does not have to rely on my experience or my intuition or my creativity. It's something that occurs, in a sense, procedurally, that if you are disciplined enough, you as a designer can create something that is very appealing, regardless of your level of creativity. That he says that the patterns that Alexander describes define relationships between the entities in the problem domain. these patterns are not as important as the relationships. They give us a way to talk about them. I got a little bit confused when I first started reading patterns because I kept thinking design patterns. I do not believe this is the case in this chapter. Usually when we see patterns, we think, design patterns, like the adaptation pattern, but this is more of patterns in general, of the sense of complexification, of adding a crinkle into the original design as you start adding new features, in a sense. I might be using bad language in a sense, where I might be confusing words, but at this point, I just wanted to make sure everyone, I think, understands that when we talk patterns define relationships, we're not talking design patterns, essentially. We're just talking patterns in general in view of design. So here are the steps to follow. You want to identify patterns that are present in your problem, and think of the problem in terms of patterns that represent. So that's kind of initially how we saw that there is this essential quality in design, and that's defined by the patterns that are present in certain cases. Like, for instance, courtyards, patterns that are present, again, are open spaces, crossing paths. So those patterns are typically found and kind of define the essence of a courtyard. Then you go on to start with context patterns, which means to identify the patterns that create the context for other patterns. So the idea there is you want to create a very reachable or buildable upon pattern, if that makes sense. You want to have a pattern that other patterns can be applied to, and something that's not too restrictive, like having a very, a parking lot in the middle of a courtyard doesn't help create nice parking courtyards. It kind of, there's something there that prohibits building on top of. Although it could be interesting to see a parking lot that exhibits courtyard like qualities, but that's neither here or there. Then you want to work inward from the context. So looking at the remaining patterns and at any other patterns that you might have uncovered from this set, pick the patterns that define the context for the patterns that would remain. Yeah, it gets very abstract at this point. From this set, pick the patterns. So if the context could be the courtyard, you might say that you would sacrifice having a gift shop if it, keeps the person in the courtyard from having a nice view of outside. So, initially it could have been like a good draw, but it's not the right pattern. So the idea is you would just want to pick a better pattern, as you're building on top of it. As more and more patterns get applied, you might have to prune some things, which is kind of part of this refining the design. Again, I'm getting very almost like these steps are not 100% clear and concrete as to how to go about creating these designs. But the impression that I get is that it's very fluid in a sense. There's this kind of loop pattern that goes on where you apply a pattern and then see if there are other patterns, and then you go on recursively through and apply and change and review to see how it kind of all fits together. So the gist that I get from this is that it's a very much a process rather than a one-time set of instructions, like building IKEA furniture. It would be really funny to see a timeless way of building furniture, but yeah. So going on, so we get finally an interpretation that our original author gives on complexification and the timeless way. He tried to use the timeless way as much as he could. And he tried to promote it as much as he could, trying to say that it's a very good approach to design and a very good approach to how we should create our programs. he kind of had some problems with it. Well, I'll just kind of go. I began to evangelize about the Alexander's approach as I understood it while teaching others. A few months and a few projects later, I began to see problems. There were cases where a preset order of context did not work. That is, sometimes a bridge pattern could create the context for a composite pattern, but sometimes it could be exactly the opposite. Having been trained as a mathematician, I only needed one counterexample to disprove my theory. This started me questioning everything about my approach, something I usually did, but I'd forgotten in my excitement. Since that early stage, I now look at principles upon which Alexander's work is based. Although they manifest themselves differently in architecture and software development, these principles do apply to software design. I see it in improved designs. I see it in more rapid and robust analysis. So I guess I was wrong because he starts actually using design patterns as those contexts. So I personally have a disconnect between in this chapter between using certain patterns to develop other patterns. Just might be my noviceness in the sense of I don't use design patterns as much as a more experienced programmer does. So I don't see everything in terms of patterns yet. So there are cases where, but what I did find pleasing was that there are certain orders that Timeless Way is based upon an order of sequences of applying patterns. What I think is interesting is that he was using a preset order, kind of almost taking a modular or predefined piece and applying that kind of modularity to applying patterns, which is interesting because now you've made a modular piece using the Timeless Way, which is kind of counter to the whole point of the Timeless Way, which meant that you want to look at each new design and think of it in terms of applying patterns one by one. When you have a preset order, it implies that you've no longer rely one pattern, but you just keep applying patterns and then reviewing it at the end. That's an interesting little nugget there. So in summary, design usually isn't a process of, design is thought of as a process of putting things together, of, I think, sometimes following instructions and making sure that everything follows as it should. In software, common approach is to look immediately for objects and classes and components, and then to think about how they should fit together. Alexander described a better approach than the Timeless Way, and it's start out with a conceptual understanding of the whole in order to understand what needs to be accomplished. Identify the patterns that are present in the whole. Start with those patterns. Create the context for other patterns. From that context, apply a new pattern, and then identify new patterns. And then those new patterns provide context for hopefully other patterns, and so on and so on. Finally, refine the design and implement within the context created and apply these patterns one at a time. As a software developer, you may not be able to apply Alexander's patterns language approach directly. However, designing by adding concepts within the context of a previously presented concepts. So concepts are patterns for us. So however, designing by adding patterns within the context of previously presented patterns is surely something that all of us can do. Keep this in mind as you learn new patterns later in this book. Many patterns create robust software because they define context within which the classes that implement them can work. So there are some review questions. I wrote down some of the answers, so I'll let anyone respond to this question, and then I'll just show what I put in as my answer, at least for the observation section. So Alexander uses the term alive to characterize good design. What terms did I, the original author, suggest using when it comes to software?
Good question. I'm sure I had something to be more with like flexible or resilient.
Yeah.
because it doesn't apply. I mean, I think just as a backstep, I thought this was like the worst chapter so far because it had the least amount of usable information. It's like I took a detour because I tried to take this literal, literally this thing of how to design architecture and move it to software architecture. But once he starts talking about like aestheticness of a like a Swiss village, well, it's true. I was actually explaining to my kids, and look at how generic and cookie cutter this is. But if you've ever been to like these nice little towns in Europe, they're different, but they fit together. I can completely say the flavor of that one, which when it comes to software, that aesthetic thing is like the highest level need. Like after somewhere, like as a programmer, like you start and number one is get the compiler to like it, right? And number two is then make sure it works. And then it's like, well, then find some bugs, then clean it. It's like these needs, these software needs, making it beautiful like a Swiss village is like luxury 11 after it was deployed, kind of thing, where that's like essential to Alexander's approach. And it makes more sense when we're talking about like, the architect that's paid a lot is because he makes this great thing that's great in a way that, because I have $1 zillion, I can pay you to design my house and I'm a little bit happier. These intangibles that are hard to measure in software at all, right? So it's like alive that doesn't even apply from that perspective as much. But the closest thing to being alive is, well, for software, code has to live forever. So it has to be flexible and pliable, the ability to change it to your changing needs. That's useful. Ruby is one of those few communities where beautiful code is a thing. So it's something that actually applies to us a little more than, say, JavaScript, which I would still say is still hideous. JavaScript as language is getting more powerful, more expressive, but still butt ugly in my mind. And of course, there's a bias, of course, but yeah. So I think the only things that could apply is like flexible or ability to be changed, to be improved, whatever.
Next question. Good design requires keeping what in mind? It's pretty open-ended, but I kind of just made it simple answer in my mind.
Someone who's not me, say something.
Not sure.
So
not sure.
I think something. I'll give it this. Al is trying to make us think more than we do. And I suspect some people will question, well, why should I think more than I have been? Like, what value is it? And there's some truth. Some of it's a little abstract, I think.
Yeah.
But if we look at that Alexander step, he's saying step back, get the big picture. I think that's the key thing. I think the biggest value that BDD brings over TDD is BDD starts from the top and drives down. So what that does is it gives you the context. Terry comes to us and says, I can't think of any made-up fabricated feature now, but I want something, and she gives us like 11 words. Well, and that's sort of why cucumbers say the intent, as an administrator, in order to process new hires, I want to blah, 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 right? That context setting lets you know what was desired. And then we can write the cucumber and say, well, given a new employee with, I don't know, no records, then blah, blah, blah. The given when then this is almost exactly that. Oh, my big picture is what's the theory intent, and then that's the as a so-and-so to get something, I would like something else. Then we have like the more programmer, given this, when that, then that, right? This is closer to big picture and then more and more detail. And so then in BDD, if you actually wrote cucumbers and implemented, you write the cucumbers first, and then you turn around from there and you BDD the classes that make those scenarios work, right? And so what you get that way is you only write the code you need because it started from the top down desired features. You know, the guys that do bottom up, well, I'm going to write a library, I'm going to write a database library, I'm going to write a check library, I'm going to write an employee library, and then we'll just Lego them together. And that's sort of the old school approach, and that's, I can think, hopefully, that some of the mistakes Alan says, this is not a good way. It's like, in some ways, that Alexander approach of start with big picture, oh, I kind of want this, and then narrow down. And so you can see each one of those narrows down might be separate cucumbers, and then the actual classes and whatnot would be the actual, now that I know the exact 3 requirements I need, which having a big picture, I know how they should fit together when they're done. That's a thing. And then, I don't know, am I rambling too much?
No, I like it.
So, yes. Okay, go ahead, sorry.
That's right. Alexander suggests that the best approach to design involves complexification. What does this mean?
I think I sort of talked about that from the BDD thing, but just start simple and add the details. The key.
I think.
Go ahead. The key hardest thing the beginner has is they don't have the experience to go, oh, this is blah, right? Start point is this. This is the context for everything else. That's really, and I think there is no way. And actually, I'm big on pedagogy as far as instructing across lots of disciplines. It's simply not someone. What do I say? You just can't do it. You cannot start out as a beginner and try to absorb. This is how the expert works. Yes, it might be the best way, but it's not your pay grade. You kind of have to learn the patterns and write them and do them, and more importantly, then do them wrong to realize, oh, guess what? I did this wrong 3 ways, so I know by process of elimination that these other ways are probably better ways to do it than the ones I did. Right? Sometimes you need that experience. You need these things. You need to understand these. You need to write your bad patterns before you understand what good patterns are. But then over time, you just start to recognize, oh, I know what this is. This is this thing that we tried to do twice and finally succeed this way. Right? And that's the kind of pattern that's, I guess, someone like Alexander looks at a courtyard and says, you know what? Wrong, this, that, but one here, boom. How'd you know that one? Well, because I built 52 crappy courtyards and finally figured out what context is. And these guys say, well, I'm so depressed because of that. It's because of this. Well, the beginner wants this little 1, 2, 3 checklist so that they can design like Alexander. It just doesn't happen. You kind of have to learn the pieces and the details and think. That's kind of what all these questions are. Think. Well, but what is think? Think is really understand. I pitch a lot of this. If you understand things at a conceptual level, the details are not as, it's a very unsatisfying answer to people who are not at the level to absorb that one. But the more you understand how and why, the less the specific details are there because you can fill them in when you get to it.
Mm-hmm.
All right, sorry.
Cool. Continued. To Alexander, what relationships does a pattern define?
All right, that's something that doesn't require.
That's a little bit over vague.
Yes.
Sorry.
So,
I'll put in.
I'll go ahead. Yeah.
I thought it's a little too vague sometimes. So these are just answers that are directly from the book. So a pattern defines entities in the problem domain. So good definitions to try to work out what is the problem domain. Problem domain would be whatever your design is trying to fix, replace, answer. You know, the courtyard is a design that a town is looking to beautify its, itself as a whole. So the problem is the need of a courtyard. I guess a courtyard is the pattern. Perhaps there are other patterns within it. So there's certain elements within a pattern that define the pattern. And then as you look at those elements, those have their own patterns as well. So there's this kind of, I get this very like chaos theory fractal kind of image of this like, montage of like zooming into different patterns in my head when I think of this relationship and patterns. So it's a little bit terribly abstract, especially since I'm using architecture instead of software. I think, Forrest, your example with BDD is a lot better, where you start off with a very simple requirement and then you start adding to it, or not adding to it, you start digging into it and saying, well, if I need to have a way to look at a prospective employee, I need to know this about it. And so you build a class and then you make sure that everything there kind of is self-fulfilling, or if not, you have to keep going deeper and making sure until finally everything kind of resonates as a acceptable solution.
Yeah.
That's.
Yeah.
What are Alex?
Go ahead. I think that one's relatively closer to simple as far as, I mean, like when I forgot the exact structure for how we define patterns, but it does start with these are the entities, and then how they relate to each other. Adapter. An adapter, you have the thing that uses the adapter, and you have the thing that's being adapted, right? What's the relationship between those two? Which, when we talk about patterns, there's always a stated purpose. What's this for? Well, I need it to look like this other object. Oh, okay. Well, I have a user and a usee, and maybe those are the wrong words, but and then this usee just sounds very abusive. So, right, but I need this usee to look like that usee. So, you see what I'm saying? There's the pattern, but the relation. You have the entities, the user and usee, and again, I'm sorry I'm using that word. I can't think of the other one. But why? What is the relationship? Well, the user can only use this kind of usee. So then I can make it look like this other usee, and now we've adapted the thing. Right? So you can see there are entities, and there's a specific relationship between the entities. And I think sometimes that's lost in beginner OOAD. They get the nouns and the verbs, but they don't define clearly enough the relationships. And the big picture is really the biggest picture stepping back of all the relationships. And actually, when you step back one, it's what do I say? It's like when you drill up, you like encapsulate. Like I might be an adapter at this level, but if I go back to the thing that's using adapters, I no longer think of those tiny things, right? Or just exactly the adapter itself. The adapter hides the fact that what you have is not what you have. It makes you think it's what you have. But at the adapter level, you might know all kinds of details. You might have like 3 or 4 classes or something involved, But at the parent level, this just looks like another one of these. So the big picture and the context pattern he's talking about is the highest level pattern that wraps everything away, or that you can. And there may not be a single one. The highest level might be like 3 or 4 patterns. Each one of them uses some stuff that maybe you have to explode other patterns to make them just like if we were decomposing the cucumber all the way down into code.
So this one's pretty, I guess, how do I say it? Rote in a sense. This really doesn't require much, so I just put it out. The 5 steps to design. Start out with conceptual understanding of the whole. Identify patterns. Create a context out of those patterns, and then work inward from the context, revealing more patterns. Repeat, and then refine the design and implement within the context created by applying these patterns one at a time. Pretty much cut and dried. So interpretations. Alexander says, but it is impossible to form anything which has the character of nature by adding preformed parts. What does he mean by this?
Let's see. Anyone have any opinions besides me, Andrew? Yeah, go ahead. It's too bad he's somewhere far away. All right. What do you think? All right, Andrew, I'll let you say. What do you want to say?
Right. Sam, you want to do it?
No, you go. I feel like I'm talking too much.
Okay. So in this sense, it's in a sense that I'm going to approach this question a little bit backwards in a sense. If I want to imitate nature by using preformed parts, I end up starting with the presumption that I know everything about nature and that all the parts that I have are enough to recreate nature. And so out of ignorance, I feel like it's a better approach in a sense. So if I want to say, I want to create a leaf, and I think that leaves are created by Lego bricks. My leaf, in the end, may resemble a leaf, but it's missing quite a number of characteristics of a leaf. And so if I instead look at a leaf and define what patterns are found within a leaf, I can then say, all right, I need to start building on creating tools that will allow me to create a leaf. So I could look at it from a concept of very basic things, like it's green, it's pretty small. I can go into more complex things and say it actually uses photosynthesis. And so now I have to try to start developing chemistry or some sort of biophysics and try to replicate photosynthesis at that level. But that's a truer approach to representing that character of nature, rather than trying to say, well, I know pretty much everything I know about nature, and I'm going to build using these parts. And I'm pretty sure that's going to come out pretty close. And it's not quite the case. I think there's a bit of pride in the sense of having preformed parts and trying to build with those parts. And that pride kind of just leads to a pattern that doesn't build on top of itself. It's already defined its solution with those preformed parts, and that solution most likely isn't going to solve the problem. That's my interpretation of it. There could be other interpretations as well.
I think that's not bad. I want to say two things. I'll do the shorter thing first. By instead of Legoing things, a predetermined Lego thing, which by the way is really fun for kids, I'm going to use specific words. You need to grow your design organically. Anyone heard that before? Does that sound familiar? I don't remember if Shalloway says that way. But that's kind of the notion of what PDD always was, to organically grow it, or extreme programming and later BDD. You organically grow things as you understand. Obviously, you have to start with something, this context pattern thing, or cucumber intention, whatever. You start with something and you kind of grow into it. I think it's him saying, you know what? You can't Lego together your answers, which ironically is the complete reason that design patterns took off like back in the 90s, because the DoD said, finally, a book that tells us how to write CLUD software, which, again, as anyone who's written any amount of software goes, it's not that easy. We cannot, we haven't been building softwares for thousands of years that we can arbitrarily build 100-level skyscraper buildings at will. We don't have that kind of Lego ability yet. We don't have that kind of understanding. And it's but that was like when design patterns were really popular, like, you know, every DoD starts like, you will use design patterns. Why? Because they're proven to be good, blah, blah, blah. So people wrote a bunch of crappy design patterns. And then they go, what happened? You wrote design patterns, of course, but we don't know how to use them. So, but it was for the hope for Legos. But it's again, this doesn't work that way. Put Lego stuff together. We can't Lego software together yet, unless it's the simplest of things, or they're all the same. Yeah.
Like it. Any other interpretations? Going once?
No.
All right. So, opinions and applications, open-ended questions. Sometimes the case that is made for object-oriented programming is that it gives you small, reusable components that you can assemble to create a program. Does this align with Alexander or contradict him? Or is Alexander speaking at a different level? Why?
I picked that Alexander speaking at a different level thing. Because at a certain point, he does use pre-assembled. Oh, you need a dove joint. You're not going to invent a new damn thing. That's proven. Right? It's just the organic. I go back to my organically grow things, which is more art than science. So I think it's the big picture. It's like, right? At some point, he's going to use nails, small reusable things. You know, at some point he's going to certain, you know, and then those get bigger. Well, you know, this is a something box. Well, he can use a miter box. Use a dove joint. He'll use, I don't know. He'll probably put a table in that he didn't have to design in his living room. Right? It can't contradict him. But I think for the previous question, there's kind of a reason why those, why our cookie cutter modern houses suck compared to some Swiss village houses. So, but I don't know if we have that equivalent of beauty for software. I know, you know, Rubius and other people that like beautiful, clean code may sort of lean that way, but I don't know that right.
Well, the idea with beautiful code would mean that it's easier to maintain in the future and more robust. So it's interesting when you said it's more art than science, but at a production or.
And I say that because you don't have this algorithm that allows you to generate consistent results. So it's art, it's feeling, it's knowing, it's at this point in time. And sometimes it's one of those you can't describe it. You just look at this guy and go, oh, God, that's gorgeous. Well, what's gorgeous code to me in Ruby? Gorgeous code is simple. Simple, but it's more than just simple. There's a... I don't know. Again, this is a... Some code is more elegant and pleasing. I don't know if you know, working on the code that you've worked on, I don't know, unless you've read enough blogs or seen good Ruby programmers, you go, oh my God, that's really elegant. Like Rails is quite elegant. The way they structured active record with the whole declarative look, it's like, that's great. It combines two things, right? For some people, RSpec is super elegant. The way they made it. In fact, RSpec is now less... Well, the question is elegant for whom? RSpec, I like old RSpec because they really tried to make it look like language, which was the beauty of, you know, in general, Ruby's ability to DSL and morph to your problem domain is something that can be really elegant. But certain ways of defining things, I should dig up some code I've written for other things where it's like, oh no, look how clearly this pushes things away, partly in the way that I can morph Ruby to look like this is a natural construct. I've lost track of what I'm talking about. Beautiful. You'll look at some things. So sometimes, okay, I know this one. So for DHH, Rails' beauty is for the guy using Rails, which of course, him being a major user of Rails, obviously kind of drives that. So, but sometimes what's under the hood may be hideously terrifying. So that's not there to make the guy who makes the magic work. It's the guy who uses the magic is the target audience. On the other case, there's a code the other way. Well, look how maintainable this is for me, but the guy who maintains the library. But then this other guy who's using the library goes, yeah, but I gotta use like extra stuff, and this is not so clear, right? And ultimately, Ruby kind of came into being because Matt said, look, I want to make the programmer, aka me, happy instead of the compiler happy. So that comes with a payment. Ruby is slower than Go, which is, more better, being low level and, whatnot. It's like, okay, it was taught different person you're trying to make happy. So in that sense, I guess Ruby has a bit of that. Yeah, anytime you use it, anytime you take the effort to DSL something that just doesn't work with objects and classes, like if you look at any of the Ruby time functions versus the JavaScript time functions. JavaScript time functions are normal and typical, and time.new, fill in 6 parameters, right? That's everyone does that. That's simple. That's clear. But one.week from yesterday is more elegant and actually less programming languages. Or not, you can write that in one time.new, right? But the brain power to figure it out is just less elegant. A lot of that active support time stuff that takes Ruby's already nice time stuff. Time.yesterday. How clear is that? That's so clear.
Yeah.
Right? That could be the same as well. Time.new.2018.12.30.11.0. It's like it's the same sentence for now, but tomorrow I have to change some of those numbers. They're both one line. There is a beauty in Ruby that kind of approaches this Alexander level of pleasing courtyards that actually doesn't exist in a lot of the programming languages, I think.
Yeah. When you were saying that, I think there's something that I keep in mind sometimes is trying to understand things and cognitive friction in a sense. If something's harder to understand, I say that it has more cognitive friction in a sense. If I'm trying to read code and I spend a long time trying to figure out what it's trying to do, it's like there's more resistance against it. Whereas if there's a very simple and easy to read code, it might be doing great things, but I can understand what it's doing exactly. And you speaking to DSL and or the time functions and showing the 2 examples of that makes me think, yeah, it's a lot easier for me to see one.week or time dot since or a current week, beginning of week, kind of language compared to trying to understand some sort of hieroglyphic combination of symbols, and it's like, oh yeah, it's just there's a level of ease to trying to understand certain things, and I think that's a great approach to design. If you make it easy to understand, it's you get people wanting to work on it and people able to do good work. So I don't want to have the last word. Forrest, you can have the last word on that.
Oh no, I'm ready for next question.
Okay, next question. Have you ever seen a courtyard or entryway in a house or building that has felt particularly dead or uninviting? As you look at Alexander's description of the courtyard pattern, what entities did your courtyard or entryway in a house fail to resolve or involve? I'll let everyone think about their most displeasing courtyard / entryway and try to see if there are like certain patterns that people can kind of.
This is something anyone can answer because I'm drawn blank. And in my mind, I'm fabricating an alley in Boston that I may have seen, which is not technically a courtyard or an entry in the house, but I'm just thinking of some red brick, slummy thing that's dirty. That's not even a courtyard, and I've failed already. So I can think of nothing in this category. I keep no courtyards or entryways in my house normally. Maybe that's why I'm not a architect or an interior designer.
Ooh, I'll come up with one. I particularly do not like what are those called? Like shopping plazas, where it's like a huge parking lot. It's very convenient. But if someone were to say, "Oh, this is our courtyard," or "This is our, center of town," and it's like almost like a highway that runs across it with like shopping plazas on either side, and to have that compared to like a nice, well-kept like downtown town center, it's like those two things are very distinct in my mind. Where one is it's more accessible for cars, but you're not able to walk from one portion to the other because there's so many cars, creating a hazard for pedestrians. I feel like one's very restrictive to a certain person, whereas the other one is much more open. It might be less car friendly because you have to go down a one-way street and there's like only one lane or two lanes. I think there's like, in that sense, for me, a nice, downtown or a nice town center, or maybe even in like a court, it's a little bit of an interpretation of a courtyard. I don't really go around a lot of courtyards, to be honest, but to just say like a nice old timey town center, you have nice shops, cute shops that you can walk to without worrying if you're going to get hit by a car. That's my opinion.
All right, so we have entities that fail to resolve or involve. So what are the entities? Humans, stores,
cars.
Hard to find things, or when you fail, or dangerous?
Dangerous, yes. What else? To fail to resolve. It's loud. It's just not peaceful. If there's like cars honking, or there could be an accident. There could be, bumper to bumper traffic, and people are upset. And there's this overall like, you can't really just have a good time walking.
This makes me interested in like retail analysis. Why does mall A do better than B? And you always hear things like stores or location, but I bet you some of it's design, some of it's clearly more pleasant to shop in than others.
Yeah.
But again, it depends on the target shopper. Right?
That's true.
Like I'm sure
that could be
upscale shoppers have a different, maybe elevated standard.
Yeah.
Than poor.
There could be that could be a poor design implementation. The mall caters a certain type of shopper, and there's not that many shoppers in the area, so you have a mismatch.
Yeah. It's an interesting level of, like, I don't know if there's a retro analysis. Hey, go to the shopping mall and then check these 20 items and get some kind of framework. Oh, well, for Shopper Big Bucks, this is a 9.2, but for Shopper Joe Walmart, this is a 3.3. So let's not build it this way over here.
I like that. That interpretation kind of takes into the effect of, where are we going to build this mall? And then who's going to visit the mall? Very, very big questions, very simple questions too, but really flesh out the details. Like,
well, I mean, there's other level things. An expensive mall is expensive to run.
Yeah.
Right. And I think for a certain category is, hey, if you got the cheapest price, I'm there. So then that means I need almost no overhead as long as I lure the right stores.
Mm-hmm. Yes.
Right. And so from the operating perspective, wow, I can have this place with Saks Fifth Avenue and these expensive Tiffany and Tesla, you know, but then I got to make it expensive and change the lights more and blah, blah, blah. So there's a operating cost that is raised. I'm going to go bring the really rich guy in. That might not be yet. Right? So, interesting. Okay. Context. Context is everything.
Think of one software project in which you think Alexander's approach would apply, and a project in which it would not apply. What are the issues? This one I have a little bit of reservation of, since most of my software projects are dealt within the company, and we try not to talk about those projects.
Yeah. You don't have to resign.
Snapchat, because who knew that they would be worth like $6 billion for the smallest functionality in the world? Would have wrote that a long time ago.
That's interesting. You know, I'd say the parts that you don't apply are like small, tiny things, right? One-offs, quick things. You know, for example, like there's that DevOps thing Andrew's trying to write. Don't design it.
Oh, yeah.
Just freaking get the 3 things you want and be done.
That's true.
So there is.
I'm still having.
Don't over-design. There's a time not to over-design. There's also, if Alexander's approach is be a master designer, which is kind of how I retro look at the chapter. Well, Alexander does this. Well, Alexander's a master designer. So, which means he can see the pattern, the high-level patterns immediately, and then has a great sense of what patterns fit inside. So I should say, well, in general, then you want to do that one, but don't over-engineer. So, the other thing you don't use is if the answer is already known.
Yes, that's a good one.
Right? I mean, you could redesign it, but you don't have to.
I would say if there was a better way of modifying that design, do that instead of saying, "Oh, this design just doesn't work," without trying it. And
right, because otherwise, if we think of his design as basically expressing BDD, well, of course, you do that as much as possible unless you already know the answer. You already know how to do it. And, well, but then maybe you're already applying his thing also. Well, I know the big context is this, and I know the subpatterns is these. Boom, done. So the fact is that there may be no patterns in your code. And yeah. Or sometimes speed. Sometimes to go with Snapchat. Sometimes getting out the door first is the most important thing to do. So context beyond. Yeah, there are other things. You're in a tightly contested market, and the first guy to product wins. So you got to get out door first, otherwise you've missed your window, and it doesn't matter how good your code is because you lost. So, all right. Is there a question for?
that is nope. That is it.
All right, I think we're completed. We went longer than I thought because probably I talked too much. Anyone? Comments, questions? It's much more of a meta-philosophical thing than a code-specific thing, which hopefully will feed the other stuff. You know, I was looking at not a lot of insights. In fact, I didn't have any insights until I was yapping. I said, "Oh, this 5 pattern kind of resembles BDD." At which point, then I go, "Oh, well, okay. If you don't do BDD, then that's a reasonable conceptual way of how you might approach things." So maybe that's what we should study. We should probably study the BDD book.
Okay.
There's a lot of stuff. All right. We need to pick who. Next chapter is short. If I recall, the next chapter is fairly short. Is that another short one, or am I wrong? I can't remember. I looked at this for 2 weeks ago, and I haven't looked at it since.
Let's see.
Diego, because he's not hitting himself.
Didn't Diego go kind of recently? I would throw it on him, but I think he's been in recent rotation. Putting it all together. So chapter 12 is how designed. Okay, 13 goes back to code. Solving the CAD CAM from, what's this CAD CAM? Let's see, I check. Oh, yeah, you're short. This one, 13 overview.
Looks like 14 pages.
Looking in patterns. All right. Does it actually? Oh, I know it's got a bunch of diagrams. Hopefully, there's something to bring us some meat. I see a lot of thinking in patterns. Step 2C, 2A. Oh, hey, I have to take this call. We'll resolve. Thanks. Hello?